bacteria looks much simpler and small compared to other organisms. After all, they are really tiny and only made up of a single cell. They do not have brains or other organs, and even their one cell looks much simpler than one of our own cells. But though they are, their behavior and lifestyle matters because they seem to be in a war. Firstly, they have been in the earth for more than 3 billion years ago, and even if human evolved around 2 to 6 million ago, they discovered the existence of bacteria. In 1665, a microbiologist, Antony van Leeuwenhoek, discovered bacteria using his own made microscope. Thanks to Diertjes, a microscope used to observe this organism. Now let's take a look at bacterium called Mycobacterium tuberculosis. Virtually all successful Mycobacterium tuberculosis infections occur by airborne transmission of droplet nuclei containing a few viable bacteria, which is produced by a sputum-positive individual with active tuberculosis. During the infection process of TB, there are several stages occur. Like any bacterium that can be present in the air, Mycobacterium tuberculosis enters human body through nasal cavities during inhalation because of its presence in the atmosphere. Note that Mycobacterium tuberculosis presented by an individual through coughing can remain from 2 to 40 hours in the atmosphere. In addition, at least 3,000 droplets of saliva each with around 100 Mycobacterium tuberculosis can be produced per one cough. Here, Mycobacterium tuberculosis droplets will settle onto alveolar lining fluid, which further disperses the droplets and reshapes Mycobacterium tuberculosis bacilli. As they encounter resident alveolar cells, the Mycobacterium tuberculosis infected alveolar lining will further trigger a series of complex and poorly understood innate immune events that will result in generation of the adaptive cellular immune response, with formation of granulomas that control infection but allow for bacterial persistence and serve as a barrier to therapy. About 1/4 of the world's population is infected with tuberculosis. Only a small proportion of those infected will become sick with TB. People with weakened immune systems have a much greater risk of falling ill from TB. A person living with HIV is about 20 times more likely to develop active TB. TB is currently one of the top 10 causes of death in the world. In 2015, 10.4 million people, 1 million of which were children, became sick with TB and 1.8 million died of the disease. Over 95% of TB deaths occur in developing countries. TB is the leading cause of death for people living with HIV. In 2015, 35% of HIV deaths were due to TB. Around 60% of the total TB cases are found in the following 6 countries: India, Indonesia, China, Nigeria, Pakistan, and South Africa. TB is one of the top 5 killers worldwide of women ages 20 to 59, and mothers with TB have a 6-fold increase in prenatal deaths and a 2-fold risk of premature birth. In 2014, the treatment success rate for people newly diagnosed with TB was 83%. The number of TB deaths globally fell by 22% between 2000 and 2015. Due to worldwide TB response efforts, 3 million lives were saved in 2015. In 2015, roughly 480,000 people worldwide developed multi-drug-resistant TB, MDR-TB, and only 1 in 5 who needed MDR-TB treatment enrolled in it. In 2015, an estimated 4.3 million cases of TB were missed by national healthcare systems across the world. This information about Mycobacterium tuberculosis and all different cases and statistics is just an example of disease-causing bacteria, capabilities, and so on. There are a lot of different disease-causing bacteria. Streptococcus is a genus of gram-positive coccus or spherical bacteria that belongs to the family Streptococcaceae within the order Lactobacillus in the phylum Bacillota. Cell division in streptococci occurs along a single axis, so as they grow, they tend to form pairs or chains that may appear bent or twisted. In addition to streptococcal pharyngitis, certain Streptococcus species are responsible for many cases of pink eye, meningitis, bacterial pneumonia, endocarditis, erysipelas, and necrotizing fasciitis, the flesh-eating bacterial infections. However, many streptococcal species are not pathogenic and form part of the commensal human microbiota of the mouth, skin, intestine, and upper respiratory tract. Streptococci are also a necessary ingredient in producing emmental cheese. Streptococcus pneumoniae are bacteria that are commonly found in the nose and throat of children and adults. Streptococcus pneumoniae can infect the lungs or ears, but it is considered aggressive when it is found in the blood, spinal fluid, or any other site that normally does not have bacteria present. Many people carry Streptococcus pneumoniae without becoming ill. Unvaccinated children, the elderly, and other people with weakened immune systems are the most at risk for invasive infection, but some people get an invasive infection for no apparent reason. Like Mycobacterium tuberculosis, Streptococcus pneumoniae are spread from person to person by the breathing in droplets produced by an infected person during coughing or sneezing. Signs and symptoms depend on the part of the body affected. Invasive infection often includes fever, chills, and irritability. Headache, stiff neck, confusion, sleepiness, vomiting, and poor feeding can occur with meningitis. The incubation period varies. Signs and symptoms of infection can occur within 1 to 3 days after exposure, but may occur long after exposure. Laboratory tests on blood, pleural fluid, joint fluid, or cerebrospinal fluid, CSF, are needed to confirm the diagnosis of invasive disease. The main treatment for invasive Streptococcus pneumoniae infection is antibiotics. Thanks to vaccines that can help to prevent invasive Streptococcus pneumoniae infections, pneumococcal conjugate vaccine 13-valent, PCV13, is recommended for all children starting at 2 months up to 59 months of age. Pneumococcal polysaccharide vaccine 23-valent, PPSV23, is used in high-risk individuals 2 years of age or older. Both PCV13 and PPSV23 are recommended for adults. The use of these vaccines is based on lifestyle, health condition, and age. Consult with your doctor or local health department to determine if the vaccine is recommended for you. Frequent hand washing with soap and water, or, when soap and water are not available, the use of alcohol-based hand rubs or gels can help stop the spread of many viruses and bacteria. Not sharing food, drinks, or eating utensils with other people can also help to stop the spread of germs. Remember, in the beginning of the video, I mentioned that bacteria are seen to be in war, meaning that these preventive measures can be followed for other different bacteria and viruses infections. Thanks for watching. If you like the content of this video, click the thumb, share the video, subscribe to our channel and press notification bell for other videos with content like this. Let us know if there is anything you want to know in greater details. See you next time.